Okay, today we will be learning uh, another few concepts of database, and then you will learn how to draw a relational model from your ER diagram. So before talking about relational model, there are few other things you have to understand. So in here, first thing is in last tutorial we have discussed about the relationship. So basically a relationship is nothing but the uh, connection between uh, entities are represented by the relationship. So in there, there should be at least one entity in order to have a relationship. So when it comes to the degree of the relationship, it is all about the number of entities that involved in the relationship. It can be either one, two, or three, or whatever number. Okay. So when there are some situations where it can be a relationship, it involves with only one entity. In the relationship, there are only one entity is connecting with that particular entity itself. So in that case, we usually name that relationships degrees 1 or unary relationships. So, usually uh, for example, for the unary relationship is when there is a situation of something like HRO, whatever department scenarios. So in there, one, there are several employees in one organization. Uh, Among those employees, there can be one employee where they are going to manage other employees. So in your batch, there are so many students, and there is a one special person called batch representative who is going to represent your batch. So the same entity is connecting to itself. In that case, we are telling that its degree of that particular relationship is 1. So unary relationship. Okay. So when it comes to more than one, it means when there are two entities are connecting each other. This is the most common scenario in the real world. So in that case, since there are two entities are connecting each other, we call as binary relationship. So binary usually represent number 2. So in that case, it is we name these kind of relationships as binary relationships. So there is one entity, it is connecting with another entity. For example, employee can be entity 1 and the entity 2 can be the let's say like insurance, etc. So then there are some instances where more than 2 entities are connecting with each other. So in that case, we are telling it can be either tertiary, etc. up to nth value. So in that case, we tell, rather than using unary or binary, we simply say number can be n-ary, right? So if a relationship has more than two entities, we call this particular special name, right? And then usually we can and then there are special thing in the relationship. We can see a word called, we can uh, hear a concept called cardinality. Cardinality ratio is another name for this particular concept. So in that case, it explains, so you know, there for a relationship there should be at least one entity to have a relationship. So in cardinality, it simply explain how many values of one particular entity is going to participate for the given relationship, right? For example, when we, let's assume uh, there are student entities there, and then there is the degree of the course entities also there. So since student is taking courses, these two entities are connecting each other, which means there is a relationship. So in there, either one student can take only one course, or many students can one course, or there can be another situation where many students can take many courses. Likewise, there are in a given scenario, for a given relationship, we can see that there are some sort of number or amount or ratio from the total value set of each entity are connecting or participating for a particular relationship. So these amount is known as cardinality or cardinality ratio. So there are one situation when there is entities and relationship, one value of each one entity is connecting with one in one record of other entity. So if we take a very simple example, so a person can only have one passport, and for a one passport there is only one owner or one person, right? So in that case, from both of entities, only one value is participating for the particular relationship. So in that case, we are telling the ratio is 1 to 1. So the relationship also 1 to 1 relationship. In Sinhala, like අපි අනුපාතයක් කියන්නේ එකට එක අනුපාතය කියන්නේ. So the same is here, 1 to 1 relationship, right? And there are some cases in one entity, only one value is connecting with many values of other table or other entity. So in that case, the ratio, the amount will be 1 to many. Many can be more than 1, right? For example, when there is some sort of online ordering system, these kind of system, there's a very common situation where one customer can place many orders, but one order is only placing by uh, cannot be placed by many customers, right? So you can see these these ratios or this amount of relationship is denoted by special words. You can identify these words whenever you are given a scenario and to identify the cardinality ratio. For example, let me highlight a word a. So a indicate only one, and here many orders. So simply many is more than one, right? And so for the customer table, it should be one. For the orders table, it should be many. So when we are representing that one, we are using one as the number one, and for the many, we only use capital M. So when there is a situation where one value of one entity or a table is connecting with more than one value of another table or another entity, we simply say the ratio is 1 to many, right? So, and there are another scenario, there is another scenario where more than one value of one entity, or usually when it comes to the real database, so the entity represent a table. So one value or one row of more than one row or more than one value of a table or entity is connecting with more than one record of another entity or table. Okay, so we can simply tell, because both entities are connecting each other with more than one value, we simply say it is many-to-many relationship, right? So in here we simply say M to M. And there is another thing that you have to understand. So whenever there is a database or table, you have to identify some sort of values or some sort of attributes in order to identify a given record uniquely. For example, I can uniquely identify you all from your email address or even your registration number, right? So likewise, there should be a key, a unique key. So do you agree with me that for a given door, for a given lock, there is only one key, right? So likewise, there should be a unique attribute or unique thing in order to identify your set of record of your database. So there are so many different type of keys in database. So let us discuss, right? So the very first key is super key. So super key is you identified as so when there is a table and when where that table has a row, So super key is group of single or multiple keys where unique attributes that can identify a given row in the table. So what if your table has whatever attribute that can identify you uniquely, we call uh, it is super key. So when it comes to your database student table, we can identify the uniquely yourselves by your registration number, then by your email address, then by your national identity card or passport. So you can see there can be either one or more than one unique attributes. So in that case, for each unique attribute, the keys we called as super key. So from among the super key, there can be uh, many keys that are that can be used in order to identify your entire table, your each row of your table. So in that case, we are calling for a given minimum super key is a candidate key. So in candidate meaning is something like it is having minimal qualification in order to become a unique attribute for your table. So it's a candidate, something like vibhaga apekshakya, right? So in order to take the exams, if one person is qualified enough, so we call candidate. So the same theory applies in database. So whenever there is a set of unique attributes where we call it as super key, from that we can have different keys in order to uniquely identify your table, right? So you know then there is a table and we can have more than one unique attributes where super keys are there, and these keys are qualified enough to become to be chosen to the database designer. It means by yourself in order to identify whatever table, right? So in student table, the database designers have selected registration number as the primary key or uniquely identifying attribute of student table from different sets of that I mentioned, like NIC, passport, email address, and the index number. So they have selected your index number, the registration number, as the primary key. So this is all about the primary key, a column or group of columns in a table which help us to uniquely identify every row in that table is called primary key, right? So okay, so and there are another key called foreign key, right? Foreign key is a key or a column or attribute of given table where it is connecting, where from that particular key we are connecting with another table, right? So for example, when it comes to like, so in database technologies you have different groups, right, up to I think 44. So for the group table you have group ID and there is a given topic, right? For the student ID, it means your table, all about you. So you have name, registration number, and so many different attributes. So as there is a connection between group table and students, we can connect each other tables by simply using one of primary key of these selected either groups table primary key or students table primary key. So that particular key will be the foreigner, will be a external key, external attribute to uh, other table. So foreign key is the key that used to connect with another table, right? So then there is another key called alternative key. So alternative key means, so when you have more than one super key, so among that you are going to select only one for only one or few keys together to identify or to as the primary key. So if there are other keys other than primary key attributes, so the rest of additional keys will be alternative keys, right? And then there can be situations where the key is created by connecting by using more than one uh, attribute, right? For example, in even student table, we can have like your first name, your second name, and your last name all together. We can identify each student. So in there, we have used more than one attribute in order to uniquely identify a student. So since we are using multiple attributes, we call that particular key is composite or is a composition of more than one attribute. In that case, we simply named that one as composite key. Right. So I saw like there are two students who raised the hand. So if you have questions, you feel free to ask now about this particular section.
Excuse me, madam.
Yeah.
Madam, can you explain alternative key again?
Okay, sure. So in like alternative key, so you know there can be a situation. Let me use like, so let's take a table. So like, so this is my table. So you have like let's say this is name and this is like ID. This is let's say like course or whatever. So let's assume for your given table, there are different set of attributes, right? And if we take so for your given table, you know that, let's assume this attribute or this column and this column can be used to identify your table. So it means these attributes are unique. So these three attributes will be the what we call super key of your table, right? From these three attributes for your database, right? You have selected, let's assume this particular column has selected by yourself as the primary key, right? But you can see that there are more than other than this selected key among three super keys, you have another two. These are having the same qualification to become the primary key. So these will be an alternative, another choice, another option to become a primary key, right? So that is why we are telling the concept called alternative keys is comes from there. Got it? So primary key එකක් වෙන්න
Yes, madam. Thank you.
තවත් විකල්පයක් කෙනෙක්. Okay. So there's another one. You are feel free to ask. Hello. I saw another two students. You can ask the question if you. Do you have more questions on these keys, cardinality ratio, and degree of the relationship? Okay. Okay. So one student is asking, for example, for the composite key. Okay. Let me share the definition with you. So in here, composite key is a key that has more than one attribute, right? So let's assume you have a table, right? So the first attribute we will say your first name, right? So let me. So F name, and like there can be another thing, something like last name, and let's assume there's another one called middle name, right? So when you have this kind of table, so since there can be more than one Pereiras in student group, right? More than Ratnayaka or more than uh, Hennayaka or whatever, right? So in that case, you cannot use that particular attribute alone in order to identify your table. So in that case, you have to have more than one attribute in order to create a unique one. So I am using uh, first name, last name and middle name all three together in order to identify a given student, right? So in that case, we are telling, since we are using more than one attribute, we simply call this is a composition of more than one attributes. So composite key. Okay, is it clear?
Excuse me, madam.
Yeah.
Is super key and primary key is the same one?
Well, there is some sort of there is a similarity between this what we call primary key and super key. So among the super key, right, you are going to select one particular key to your database. Is it clear? So I explained you before, for a student table, there can be your national identity card as a one key. Then your email address and then your registration number, right? So there are more than one super key. From these keys, you are going to select one particular key in order to uniquely identify your student table. So that particular selected key, chosen key, is called the primary key. Is it clear now?
Yes, madam.
Okay.
Thank you, madam.
Okay, sure. So shall we like move to the relational modeling? Or do you still have question? Okay, let me share the content. Okay, so right. So far, so you have identified the basic things of database and you have some sort of graphical representation your database. For that graphical representation, we called as ER diagram. So this is not the real one, right? You cannot store your data in a ER diagram. So we have to create this particular logical or conceptual design called ER diagram into a place where we can store the data, right? So in order to create tables that is able to store different set of data, you have to do one more step, right? So since like for ER, this is your outcome, right? This is your ER. So you can't find a table format in here, right? So you need to create a table format in order to see how you are going to represent real data as the table. So in here you can see these are the different set of nice symbols, right? So you have to convert it into table format, right? So this is the all about relational model. Okay. So you can once you have the access to this particular node, you can read these are the theoretical things. So the same thing that I have explained. So and when it comes to the ER, you have learned lot of different words and different concepts and different symbols. So likewise, we have additional set of some sort of small definitions. So in here taxonomy, I have listed these words, right? So there's the very common word called tables. So in tables, uh, in tables, so when it comes to the relational model, I said you before, so in relational model, we are going to create some sort of a format of a table in order to store your actual data, right? So that so the table is the format that we are going to use to store the data of our database, right? So you know each table has rows and columns. So rows are represented records of your table and columns represent the attributes. I will show a simple diagram and explain further. So and then there is a okay, you can see that one, right? So when it comes to your let me draw this. So this is called student and it has like one attribute called ID and another has like name, and then you can have DOB and address, right? So this is your ER for this particular table, right? So you have different attributes. So in here 4 attributes. You can see when we convert ER to a relational model, we are having a result called a table, right? So the entity or the student entity will be the table, student table, right? And then the attributes will be each column of your table, right? And then we have identified key attribute like here, right? This is your primary key, right? So this will be the your key of your relation or your table. And when it comes to one single row, right? One single row will be called as tuple, right? So this is the what you call new words fallen under the relational modeling and the real representation, right? So you will learn each things one by one, right? Right. So as I explained, we have the table, and for each table has rows and columns. These uh, columns represent the attributes and rows represent records. So for the word records in relational modeling or the database world, we are simply saying it as a tuple. Okay. So, and then you can have like relational instant, relational schema. So uh, you just read these concepts, and these are like some sort of words that we are using. And another important thing is relation key. So it is basically the key attribute of your table in order to identify the each tuple uniquely, right? So then like these are the background knowledge you need. So, and then there are few steps you need to perform in order to convert sorry in order to convert uh, ER diagram to relational model, right? The very first thing is now you can do. First step is nothing to you. I have corrected many answers and they are having very good understanding of the ER diagram, right? So first thing is you need to draw your ER diagram. So you have to consider each and every detail and you have to draw your ER diagram. So once you have draw your ER diagram, you need to understand very special important information in order to design in order to convert ER to relational model. You need to understand what are your entities, what are attributes, and what are the specially primary keys, right? And relationships, right? So for the when you identify relationships, you need to have to identify the degree of the relationship. It means how many entities are connecting or participating for a given relationship, and the cardinality ratio, how many uh, values of a given entity is participating for the relationship. So these detail you have to understand, right? Once you have understand, you need to convert each of these things to tabular format or table format, right? So once you have identified, you have to convert the ER model to relational model by using following cases, right? So we have 9 cases. These are very simple once you have a very good understanding, right? First thing is, I have told you that you need to identify what are your entities. So let's talk about how you going to map entities to relation model, right? So let's assume this is your one entity of your ER diagram. So it is nothing but person. So you have different type of, I think all the types of attributes that you have learned, right? So you know that entity is representing a table of your relational model or final what we call final database. So since your entity's name is person, you simply map your each and every entity by simply writing the entity name, and you have to open and close two simple brackets. Is it clear? So when you have to convert entity in a ER diagram to relational model, you simply write down your entity's name and you need to open two what we call brackets. That is all about the way you are going to map entities to relational model, right? So once you have write down each and every entity in this particular format, then you have to think about the second point, which is attributes, right? You know, we have different types of attributes. So for some of them, we have to use special scenarios, right? So let me go through one by one. So when you have simple attributes for your entity, you just write down your names, your attribute names in the brackets, right? So you know this is the thing that you have write for the entity. You simply fill each and every simple attribute names. For the product, you can see that name and price is here. So since these two attributes are simple attributes, you simply write down price and name by separated by a comma, right? And so for the like at a glance you can see there are only two attributes, right? But remember there can be additional attributes. For example, foreign keys you can have, and these foreign keys are not represented in your ER diagram, right? So we will go through one by one, then you will identify how to get the foreign keys as well, right? But remember, there's only one key, which is primary key is always we have to represent in ER diagrams, right? And so that's why I have highlighted here. There may be additional attributes like foreign keys in table not found in the ER diagram, right? And then so you can see we have attribute called derive attribute. So it is something like we are doing some sort of calculation from other attributes. So in relational model, you are lucky enough, you are not going to add derived attributes to your relational model, right? Simply you can forget about those derived attributes, right? So and then there's another case, you can have composite attributes, right? In given entity, right? So in that case, you have to forget about the bigger attribute. It means the composite attribute you have to forget about, but you have to enter each and every atomic level attribute, right? So if I right, so the name is our composite attribute, right? So these are the atomic level attributes. So when you are going to map composite attributes to a relational model, you simply forget about this composite attribute and you have to enter uh, atomic attributes only. Okay. Right. So as I write, so as I explained you simply write the entity and you simply forget about the composite attribute and you are writing each and every attribute, so atomic attribute in what we call in the relational model, right? So there's one student is asking about derived attribute, right? So let me revise the derived attribute as now. So there can be situations, so let me take that above example. There can be some attributes. So in these attributes, you are not going to enter any value, right? Instead of entering, you simply do some sort of calculations and come up with a value. So when you know about date of birth, you can calculate a age. So when these kind of attributes are there, we simply call these things are as derived attribute. Okay. So I now believe you can, that particular student can understand. If not, you are feel free to ask at the end of the this today's session, right? So and like when you know about working hours for a given employee, you can calculate whether uh, you can calculate your overtime, right? So you know these are the hours for a given day. So let's assume 8 hours. So if one employee's working hours are 10, so that particular employee has done additionally 2 hours overtime. So this is another example for a derived attribute. You can simply calculate overtime hours, right? So when it comes to multi-valued attributes, it means an attribute can have more than value. For example, you can have more than one telephone number, right? So in that case, you need to create new relation and connect each two relations together, right? So in here you can see the multi-valued attribute is contact, and apart from this particular what we call entity, sorry, what attribute, you can have different uh, different attributes, right? Student number, name. So if I go through with my previous knowledge, so I can see I would like to type student number as the first one, and remember you have to underline your ID, you need your key attribute. So you can simply identify this is the student number is your primary key of your given what we call uh, entity. And then when it comes to composite attribute, you have to forget about the composite attribute and you have to write down each and every atomic level attribute. So I'm writing this one as like this, right? And then we have a very special scenario which is multi-valued attribute. It's all about contact, right? So when it comes to contact, so as your knowledge, this is the way you are going to, normal way. But since the contact is having more than one value, you cannot keep in the same relation or same table format. So you need to have a new table in order to maintain this particular contact. Okay, so when it comes to this situation, your solution will be something like this. Let me minimize. Okay, now you can find. See, the normal things are write down in here. Since the contact is having more than one value, which is multi-valued attribute, you simply create a new simple relation or table and write down your attribute contact in here. Since this is all about student contact, I can use student contact as to identify this particular table or relation. So in order to connect this what we call student and student contact relation, I can use student number in order to connect these two relations, right? So you can see this is the very first scenario that you can have a foreign key, right? Since for the contact, student key is student number is not given, right? But since in order to connect to these two tables, you can simply call student table's primary key or the student number as a foreigner, as an external attribute for the newly created table. Okay, is it clear? Now you may understand what is the exact thing of this foreign key, right? He is going to connect someone as the external one, right? Then there can be another situations that given relationship can have attributes, right? So in that case, even though this particular relationship is not, of course, relationship is not considered as an entity, but the case is this relationship has attributes for what we call this relationship. So in that case, you have to consider these kind of scenarios as a table, right? You have to treat same as the where you are going to treat to the entities, right? You simply write down your relationship name and open your brackets and write your whatever uh, attributes inside of that one, right? So this is how you are going to represent relationships when the relationship has attributes, right? Okay. Then there is another scenario. So please take this point as much as clearly, because since the majority of your databases, I have seen that you have like introduced weak entities, etc. So when you are going to convert weak entities to relational modeling, so you need to understand very well in this point, right? So let's assume we have this kind of a ER. So it has customer and order entities, and customer has two attributes, and relationship among order and the customer is custom orders, something like that, cust order, right? So the order is a weak entity, because if there is no customer table, order is not going to happen. So you can see there is a dependency. So order table, order entity will be considered as a weak entity, right? So in that case, you are simply first thing is you are simply write down whatever uh, way that you have learned in here, right? For example, let me write down here. So when it comes to the customer, I can simply write the entity, convert the entity into relation, and I can use C name, comma, then the address, right? So if I write down order, so it will be order ID, comma, date, right? So do not forget to underline. In here, you have to use what we call so in here there is the customer and there is the order, but you can't have a common attribute in order to maintain a relationship, right? And don't forget, this particular scenario is in order. This one is a weak one. So we have to show these tables are connected each other, and order table is dependent by customer. So in that case, this one is the strong entity and this one is the weak entity, right? You can simply introduce the primary key of strong entity to the weak entities relationship as the foreign key, right? So you can see that I have write down the customer table and the order table, and then what I have done was I have simply write down or introduce the customer table's primary key to the our weak entity table, which is order. So simply I have done C name in here. So these are two now connected. You can see that, right? Okay. So in the definition, you can see you simply add the foreign key as the primary key attributes to the owner or the weak entity attribute, right? Okay. So far, you have learned, okay, here, how to represent entities, how to represent different type of attributes, how to represent keys, especially primary keys and foreign keys, and then the relationship. And now the most important thing is the degree of the relationship and the cardinality ratio, right? Usually in relational modeling, we are not going to consider much on degree of the relationship, but we are considering on what we call degree of the relationship, cardinality ratio, right? So in here, you know that there is a concept where the ratio can be 1 to 1. So this is the very common and very easiest representation, right? So you can see we have year entity and staff entity. So these are two connected by year tutor relationship. So only one staff member is tutoring only 1 year, right? This is the way of this particular one-to-one relationship. So in this case, you are feel free to you are feel free to translate your year to relationship as you want, right? So you know, since we have two different entities, or simply a relationship is there, so you have to see a connection point between these two entities. So in there, you can see, you know, in order to maintain a connection, you can simply introduce one of entity's primary key as the foreign key of another table. Okay, so when it comes to the one-to-one relationship, you are feel free to either use first entity or second entity, since this is having same ratio 1 to 1. Okay, so okay, in here I have used year table as the same. For the staff table, I have introduced primary key of year entity, right? So if someone wants to represent in other way, so it means something like this. So you have year table and year is there, and you have staff table. So you have like name, comma, room number, right? So you can see that for the written down in the note in the red color, I have used that. I have connect these year and staff table each other by using year tables, year entities primary key. Or I can do the other way around as well, since the ratio is 1 to 1. I can simply introduce name and room number in here. Okay, so then you can have a connection between these two tables. This is very easy because you are feel free to do whatever thing, right? So when it comes to many to one or one to many relationship, so you can see that in the definition I have write down that primary key of the entity representing the one becomes a foreign key in the many side. It means simply, so you know staff is having ratio is 1 but the student is many, right? So in this case you are introducing uh, like what we call primary key of one side, the ratio which has 1, basically the staff. So name and room number primary keys are introduced to the student table, which is all about the many side, and you are going to connect these tables together, right? So you can see that you simply write down the one side, the entity, you convert the entity which is having 1 as the cardinality ratio. So you are simply having the normal way of your staff over cardinal ratio one side entity, and then you are writing your many sides entity which is student table, and simply you are introducing this particular one side primary keys to many sides entity as the foreign key, then you have the connection, right? So this is little bit harder than the one-to-one relationship, because you have to always you are not feel free to do whatever thing you want, right? So you have to find one side and the many side. You simply introduce one side's primary keys to many side entity as the foreign keys, right? So then the last case is many to many relationship. Okay, one student is asking very nice question, right? Are we wanted to show the relationship with arrow? Yes, exactly. Because, so let me show. When you have two what we call lines, it is easy to identify these are two connected, right? So since the staff, so staff, I mean the primary, these are the name and room number is the primary key. So these are going to connect with another table as the foreign key. So you simply use arrowhead to foreign key, then you can have a very clear understanding, right? Even you are connected these two with a single line is okay, but when you using arrowheads, you can have a very very informative understanding, right? You don't need to think this one is the primary key or this one is the foreign key. You can simply see that, right? That's the purpose of using arrows, right? And that is a very good question, right? Okay. So when it comes to many to many relationship, so you simply, you can see these are the two tables. You are simply creating a new relationship, right? the way that we have done to the multi-valued attributes, you newly created the one table or one relation. So you simply introduce another new table, and you are introducing to that particular newly created table uh, in order to connect these two entities or two relations or two tables, you simply introduce each and every table's primary key. You can see here this one and this one to newly created table. Then you can have a relationship, right? So if I try to write down this one, okay, you can see now. Right? So you can see that student and course is having many relationship. So you can note down that in here I have used M and N. It is also a possible, I mean, it is also accepted. Simply you have, even you are using M to M or M to N is also accepted. Okay, nothing to worry. Okay, I mean, don't panic, right? So these are the same as okay, let me write down, right? This N, even this can like be M, that is also accepted. It means like simply M to N is also correct, M to M is also correct, right? You can see that a very important thing, you can see that many and colon and then many. So you know, when we are going to represent a ratio, anupathyak represent karnakotta, we are using double dots. So that is why we are using this particular thing, right? Okay, so right. So you know that okay, so you can see that you simply write down, you simply convert your student entity to a relation like this, and then you have created, you have to convert your course into another what we call relation, this one and this one, and then you have to write down a new table. So and then there is like you, since these are having many to many relationship, you have to introduce a new table. So in here I have used the relationship name to show these tables are connected by enrolled table, right? So in the industry, it is this is the best practice. So when you are having a scenario like man to many relationship in order to represent, so you can use the relationship name as the newly created table, and then introduce the primary keys of other two entities, right? So in my site, when I'm typing enrolled table, so I have done a very silly mistake actually. So this course number should be deleted, and I have to write down exam marks in here. So if I corrected this particular relation, it is something like enroll. Course number, lab mark, student number, then exam mark. Actually, thank you for letting me know. I did not notice that mistake. Okay, so this will be the corrected what we call relation sheet, right? Relation, right? So this is the way you are going to represent when you have many relationship, right? So now you have homework to do. Thing is like yeah, one student is, yeah, you can ask.
Excuse me miss, මේ
Oh,
අප මේ ER ඩයිග්‍රම් එකක් කියන්නේ අපි දැන් ඩේටබේස් එකක් පාවිච්චි කරලා හදන කියන්නේ සොෆ්ට්වෙයාර් එක වගේ පාවිච්චින ඉන්ටර්ෆේස් වගේ මොකක් හරි දෙයක් නෙමෙයි. ඒ කියන්නේ දැන් අපිට ඩේටබේස් එකේ තියෙන්න ඕන නැති එන්ටිටි එකක් වුණත් අපිට ප්‍රොසෙස් එකේ ඕනනම් ER ඩයිග්‍රම් එකේ දාලා දෙන්න පුළුවන්ද?
okay, so ER diagram so ER diagram is only a conceptual thing. Okay, we can't use ER diagram even as a user interface, right? You can't you cannot load this particular diagram into your what we call web application or mobile application, right? So we simply, as the very first page I have shown, so ER diagram is a concept. We cannot convert this into we cannot use this ER model as it is in the database. That's why we are doing relational model. Okay, relational model is simply try to figure out our format of our tables, right? After the relation model, you have to do a very simple step, and then you are able to convert these relation conceptual modelings or logical modelings into real physical database, right? And I think is it clear? Or you oh yeah.
මැඩම් මේ එතකොට මේ දැන් අපිට දැන් එක කියන්නේ එන්ටිටි ER ඩයග්‍රෑම් එකේ තියෙන එක එන්ටිටි එක තියෙන මොනවාරි ඩීටේල්ස් පාවිච්චි කරලා ඒ කියන්නේ තව මොකක් හරි එන්ටිටි එකකට අපිට ඕන් يعني සම්පූර්ණයෙන්ම මොනවා හරි يعني ඩිස්ප්ලේ කරලා يعني ප්‍රොසෙස් එකට ඒ කියන්නේ ප්‍රොසෙස් එක ඇතුළේ මොනවා හරි ඒ කියන්නේ අපිට පෙන්වන්න ඕන නම් ඒ කියන්නේ අපි දැන් සිද්ධිය يعني ප්‍රොසෙස් එක ගන්න ඕක වෙන්නන්නේ. එතකොට මේ එහෙම එන්ට්‍රි එකක් ඇතුළත් කරන්න පුළුවන්ද මේ ඒ කියන්නේ ඩේටාබේස් එකේ නැති වුණාට ඒ කියන්නේ හදන එකේ ඇතුළට ER ඩයග්‍රෑම් එකේ තියෙන
when it comes to the ER, right, we are not going to represent processors. We are simply trying to represent the place, the structure where you're going to store your data, right? For your process, there can be some sort of special variables, right? I mean, like in real scenario, we are dealing with the ER. Okay, but like, so you are simply asking something like ER එකේ නැති දෙයක් database එකට දාන්න පුළුවන්ද කියන එකද? එහෙම නැත්නම්
database එකේ නැති දෙයක්
ER එකට පුළුවන්ද?
database එකේ නැති
yeah, it's possible. for example then අපි ගමුකෝ මෙන්න මේ table එක වල so you can see that particular ER, right? So in here I have never shown an attribute called age, but I have birth of date. From that I can have do some sort of process or calculation and can display age in your system, but that particular value is not going to show in the database. Yes, I think you now understand, right?
Right. Yes, madam. Thank you.
Okay. So are there any questions regarding to this modeling or whatever things? Okay, so you will have to do this example, do this exercise, right? So we will share this particular note in the Teams as well. So you can see that this ER has weak entity, derived attribute, multi-valued attribute, then one-to-one relationship, one-to-many, and many-to-many, everything we have learned, right? So you need to have relational model and you need to send it to me or either Mr. Pawan, right? Okay, if you have a if you can do this one without, I mean, even you can do mistakes, right? So it's okay if you try. So whatever industrial level database is nothing to you, because these are the all concept that in the relational model, right? And this particular exercise has each and every aspect. Okay. So shall we wind up the session today? I will share this tute as soon as possible with you through the system, right? Thank you for joining today, and thank you very much for supporting me by asking so many different questions. Thank you very much. So even if you have questions, you can ask through the email.
මැඩම් කවදට කලින්ද කරන්න ඕන?
ඕගොල්ලොන්ට ඊළඟ සතිය අලුත් යුනිට් එකක් මම හිතන්නේ රිලේෂනල් කැල්කියුලස් එක කොහොමද වෙන්න ඕනේ? within 1 week වගේ
ලින්ක් එක තියනවාද මේ Teams එකේ තියෙන්නේ?
සබ්මිට් ලින්ක් එකක් මේකට නෑ, බට් ඕනනම් මට මේල් කරන්න පුළුවන්. සබ්මිෂන් ලින්ක් එක අපි දාන්නේ අර group activity එකනේ. මේක අර නිකන් ඔයගොල්ලෝ ප්‍රැක්ටිස් වෙන නිසා මේබි ඕනනම් මම එහෙම ලින්ක් එකක් හදලා දාන්නත් පුළුවන්.
ඕක යටින්ම නේද?
Yeah.
හරි. thank you.